probably that. But let me get there and we'll see. All right, so the velocity of a particle, v of t, in feet per second, moving along an x-axis is given by the graph below. So first of all, we've got to wrap our minds around something that's difficult here. This is not a graph representing the particle's location. This is a graph telling me the particle's velocity at any given time. So you can't see this particle. Matter of fact, I was careful to label this as the t-axis so you don't think this is the axis it's moving on. It's not. This is time. Okay? And then this is speed. So basically what you're looking at is the speed of the object at any given time, or not speed, velocity. The velocity of the object at any given time. Yes?
Can you retell us what velocity is?
Velocity is speed, but with direction. How fast it's going and in what direction it's going. All right. So what is the particle's velocity at t equals 5?
5, right?
It's down there. It's negative 4. So that's negative 4, and our units are feet per second. So if you didn't put your units, put your units, okay? Yeah. Okay. So Nick said 4 feet per second to the left. That would be fine. Instead of negative 4, you could say 4 feet per second to the left. What is the particle's velocity at 3?
5 feet per second.
5 feet per second. What is the particle's speed at t equals 5? Speed is the same as velocity, but doesn't pay attention to direction. So it's actually, no, it's going to be 4. Because it's the absolute value. So we just take this answer and take the absolute value. Speed doesn't care about direction. Yes? Oh, I'm sorry. Okay. What is the particle's speed at 3? That one's 5. Because the absolute value of 5 is still 5. All right. What direction is the particle traveling at t equals 2? Because it's a positive velocity and we're moving along the x-axis. Positive means moving to the right. Today we're going to be looking at questions where you're moving along the y-axis. So positive would mean moving up, right? All right. So let's go ahead and continue on here. So this was a good review thing. I think I'll probably start my 6th period off by reviewing what speed and velocity is, because I thought maybe you guys would remember that, but it seemed to be a little rusty. But you guys are getting it now, so you guys are.
It sucks that we're the guinea pigs.
I know you are the guinea pigs. That does suck. What direction is the particle traveling at t equals 7? Because at that point the velocity is negative. It's traveling left.
Yeah.
All right, so next one. How far does the particle travel from 0 to 4? Now, how do we get 20?
Because it goes 4 and then it's 5 because
That's right.
I saw the graph.
So we're traveling on that interval from 0 to 4. What's my speed?
5.
5 feet per second. And how many seconds are we doing that for? The seconds cancel, and I'm left with 20 feet traveled in that time period, right? All right. Now it says here, if the particle starts off at 3, where will it be located after that? We went 20 feet to the right, correct? Because all this is moving to the right. You guys agree?
Yes.
So if I'm at x equals 3 and I move 20 feet more to the right, then now I'm going to be at x equals 23, right? All right.
23 feet.
If the particle starts off at x equals 3, this is an interesting one. Where will it be by t equals 8?
7 feet.
7?
Yes.
Okay, now let's figure out how and why. So can somebody, who can explain it? Let me go to Dave. Go ahead, Dave. What did you do to figure this out?
All right, so from the interval 0 to 4,
Uh-huh.
you're moving at 5 feet per second for 4 seconds, so that'd be 20. And then from the interval from 4 to 8, you're moving negative 4 feet per second, so that'd be a net negative 16.
Oh, so 4 feet per second for 4 seconds is negative 16.
Add those up and it's 4.
So what happened was this object moved 20 feet to the right, and then it moved 16 feet to the left, right? Okay, now what?
And its initial condition.
Yeah, that's actually true.
All right, its initial condition was 3, so plus 4. It's fine with this.
There you go. Very good. Beautiful explanation. Yeah. Okay. So if the particle starts off at x equals 3, how far will it be from its original location by t equals 8. And so what's the answer?
48.
4. Now, that's important. If you take the result and add it to the starting point, that gives you where it's at. But if you take away the original from that, that just tells you ultimately what was its net change. It moved 4 feet to the right. Yes, it went 20 to the right and then 16 back, but if you combine those, the net change was 4 feet to the right. Does that make sense? You just catch the net change word there? All right. All right, let's go ahead and move on. So now you were asking about 11, Luke, so let's see what's up with 11.
It's either like 36 or 4.
So it says, what's the total distance that was traveled by the object? So what do you think, Luke? 36 is right. So if I ask you how far you traveled on the way to somewhere and back, you're going to add those together, right? You don't really pay attention to the sign, you just add them up. So yes, it's 20 and 16, which is 36.
Well, that should be on there.
Did I put it on the wrong place? Oops.
But it's okay.
No, it's not.
What? People understand.
They would. People are generous. Find the integral v of t from 0 to 4. Now, hopefully at this point you guys know that means the area under the curve, right? So let's go back up here. And if I wanted to find the area under this curve from 0 to 4, that's pretty easy because it's just a rectangle. Okay, good. And what do we get? 20. All right. The next question asks us find the integral from 4 to 8. What's that one going to be?
Negative 16.
Oh, do those numbers sound familiar?
Whoa, that's like the distance we traveled.
Mr. Bailey, you forgot to explain the contents of the problem.
Oh, thank you. Yes, I did. Let's do that.
You're welcome.
So that's the connection that I want you guys to be making here, is that the integral basically tells you what? How far it moved on that interval, right? So this represents
The distance traveled from 0, which is less than t, which is less than t.
sure.
Oh yeah.
That's
Same,
better. You're
same,
right. You
same.
should probably write it like that. And this one is all the same thing, but just from 4 to 8. But we're still, I don't know, I kind of feel like we're missing something here. Let's go ahead and take a look at 14. So 14 is what?
4.
4. So you could say that's the net change, but that's not a very good explanation in terms of and I like that answer because it connects to what we learned last time, right? We learned last time that when you integrate a rate, you get the net change, right? And that makes sense. The net change was, it changed by 4 spaces, basically. Yes, it went all the way 20, then back 16, but ultimately the total change was just 4 spaces. So what does that represent in the problem, Luke?
It's the distance from the original position.
Okay.
The displacement.
My phone is going off. How do you know that?
I can take the physics.
Physics, okay. So it's where it's located relative to the original spot. So it's 4 spaces to the right. Now, how do I know it's 4 spaces to the right? It's positive. It's 4 spaces to the right of the original location. There's a word for that. How far something is from where it started is called displacement.
Whoa.
Okay, that's one of our vocab words for today. How far it is from the original location is called displacement. All right, next. Last question. So notice that we're finding the integral of the absolute value. Okay, so what's that?
The total distance traveled.
There you go. So it was 20 and negative 16, right? But if we're doing absolute value, it's 20 and 16, which we've already said earlier. That's 36. And that represents not its displacement. It doesn't represent how far it is away from its original location. It just represents the total distance traveled.
Going to LA and coming back.
Yes, Moses.
So it's absolute value, but it's 16. Yeah, 20 plus 20 minus. No, 20 plus negative 16. Sorry.
So let me answer your question. The 20 and 16 happen after the integral. Okay? Those are your big F and big FB minus big FA, right? So those happen after the integral. Now let's think of it more this way. We're taking the absolute value of V, right? Don't you agree this is a graph of V?
Oh,
So if I take the absolute value of this graph, that line just jumps up here.
Yeah.
Oh, actually it jumps here, not right next to it. It's less.
That was really wow.
So now my area becomes two positive values instead.
Yes.
Okay? So absolute value flips the velocity graph over. All right, it doesn't, so yeah, I hope that clarifies it. Anyway, let's go ahead and jump into our lesson. Now this lesson that we're going to do, I printed notes for you on the other side of your handout there. We're going to spend 2 days on it. We'll see where the cutoff point is, and see how far we get. These are really great. This is a great lesson for FRQs. They have these particle motion problems all the time, like on your blue books. Don't they have like the title of, yeah, you guys will see there's a whole section devoted to particle things, 109 to 130. So very common questions on the AP exam. All right, so today we're going to use integration to find what we just talked about. Distance, the absolute value, the integral of the absolute value of the velocity. That's what we saw in our last problem there, right? Displacement, the integral of the velocity. That was the second to last problem that we had, right? And or the position of a particle moving along an axis. That's like your net change plus your initial condition, right? Which is very similar to what we did last time. Yeah. That's how they word it. Yeah, I don't know why they make it a particle, but they do. Yeah. Anyway. I don't know. All right. I'm going to skip that slide. We'll jump into this one. So, displacement, you guys, is the net change of your position. Okay? We saw that on our worksheet. It was number 14? What was our, how many problems was on this?
15.
So it's number 14. On number 14, we saw that when you take the integral of V, we got 4, which tells you how far away that particle ends up landing from its original spot. That's its displacement, how much it was displaced. But to use that same word, isn't that just net change when you integrate a rate? So it also means, what was the total amount of change? Well, it moved 4 spaces to the right ultimately, right? So that's net change, connecting it to last time, but today we're going to call it displacement with these particle problems. How far an object is from its original location. If you have a positive number, that means it's to the right of its original location. If it's negative, it means it's to the left. Now, if we're moving on a vertical axis, it's above versus below. Okay? All right, distance. If you take the negative and out of there, now we're no longer paying attention to whether it's going right or left. We're just adding all the total distances together, and you end up with the total distance traveled. So instead of getting 20, take away 16 with 4, we have 20 plus 16, which is a total distance of 36 feet. So if you take the integral of the velocity, you get the total distance regardless of direction. Okay, so some key words there, vocab words. Displacement versus distance. What's the difference between them? That's, okay, so conceptually, what's the difference? Displacement tells you how far it is away from the original. Distance tells you how far the object went to get there, right? Procedurally, what's the difference? This one's an absolute value, that one's not. Okay? So let's go ahead and jump into example 1. I believe it was printed for you. I kind of was debating with myself for a while about whether or not I wanted to do this by hand or on a calculator, and I just kind of ultimately decided we'll just do the calculators. I don't want you guys to forget how to do your integrals by hand, but at the same time, time is upon us, so we're going to use our calculators.
3, then 3's cancel out, so t to the third. Minus
Yeah.
4, t to the
Yeah,
second,
you got it.
24.
But we're going to use calculators, so no stress. Here we go. For each problem below, v of t represents the velocity of the particle at time t. S of t represents the position of the particle at time t. So we have a velocity represented by this function. So if you plug in any given time, it will tell you the velocity of the object at that point in time. The S tells you its position. This means that at t equals 0, it's at position 4. Now, does it say where it's at, what axis it's moving on?
No.
Okay, we need to add that. So let's say that it's moving on the x-axis, shall we? Yeah, let's do y-axis.
Yeah, let's do y-axis.
Let's do y-axis. We did x-axis already. Let's do y-axis.
Yeah.
So add that onto your directions there, because I didn't
It's
include it
only
myself.
a different direction.
Another mistake.
Up, down.
I can't understand these notes.
Shut your face. All right. So find the distance. So what we learned from our opening activity is that distance is the integral of the absolute value of v, right?
Yeah.
On the interval from a to b. So let's go ahead and fill this out. What is my a?
0.
We're going from 0 to
T6.
6. That's my time interval, right? They're asking how far I went on the time interval from 0 to 6. Now, my velocity function is
3t squared.
Minus 48t plus 1.
That's right.
okay. That's going to tell us the distance. Now, before I calculate that, let's write the next one as well. This one's asking for the displacement of the particle. So the difference will be what?
It's not a.
There's no ABS.
It's not an absolute value.
It's just
It's just the
3t squared minus 48t plus 144. There's no absolute values. Thank you for the DT recommendation. All right, where is the particle's coordinates going to be after 6 seconds? All right, so this is a net change problem, right? The position of the object at time t is going to be its starting position
Minus.
plus its displacement.
So it's 4 plus that answer.
Exactly.
Wait, what now?
I'm sorry.
You probably could have figured this out if I hadn't written it. It probably confused you, but I wanted you guys to see this because that looks familiar, right?
Yeah.
That's what we did last time.
That's net change.
Your final amount is equal to your starting amount plus your net change. Now, in the terms of this particles talk, the final position is equal to the starting position plus the displacement. It's the same idea, different words. All right, so now we're going to use our calculators. Now, I want you guys to do these for me on your calculators.
216.
Now, if you guys don't know how to find the absolute value function,
296.
you're going to press, it's under math, and then you go over to NUM, and it's number 1. So push math, scroll to the right where it says NUM, and then push 1 for abs. All right, so I'm going to let you guys go ahead and calculate those. I'll calculate them too and let you guys know if you got the correct answers. So for this one, we're getting 216. Now, don't forget your unit, 216. Oh, it doesn't give us units, does it? So we're not going to put units. They didn't give us units. How about up here?
296.
Okay, and then where does this object land?
220.
So you take your displacement. That means it went how many spaces?
216.
To the, or which way?
Right. Up.
Up.
To the up.
That's the y-axis, you guys. That's forward.
Why you gotta do that to us? Why you gotta do this?
Because he said so.
Did we need y-axis?
Yes. I'm trying to figure
So
out.
why does it matter? I don't know. What if you had a multiple choice test where they wrote your answers like this?
Well then, God matter.
Yeah, now it matters, right? So you got to be careful. Pay attention to what axis you're on. All right, so student practice time. You don't have to write anything down. Just have your answers ready for me. There you guys go.
Oh, Hara. Don't stop.
Yo, do you ever wonder if they actually use that spell this year, man?
No, I don't. Let's see what you guys have gotten out there. Need to find your guys' class cards though. There we go. Shh. Be quiet, please.
Yes, sir.
Let's get it started. Stop smiling, Will.
Guys, set your faces. All right, here we go. Brandy, what did you get for number 1? 2000 what?
2,611. I just rounded it up.
No, you're supposed to do 3.
Like that? Okay.
Can
All right.
I just round it up to 2,611.
I wouldn't, not unless you're specifically told you that in the instructions. I wouldn't. You can also do that if you're talking about something that can't be decimals, like people or frogs, like we were looking at last time.
People can be decimals. 0.5 of a person is a guy in a wheelchair.
Yeah, you guys shouldn't say stuff like that. Amia,
Now you can't.
what'd you get for number 2?
There's
200.
2,500.
Oh, I think you're looking at the example.
Oh.
What'd you get for the student practice one?
I can't find where I did it at, but I think I wrote it.
Don't worry, I'll whisper it to you.
Oh, okay, 2590. 2580.
It's going to be 2580. 2580. Williams restroom. Zach,
Hey!
what's the last one?
2009.
Okay, good. All right, so that's that. Yes. Huh?
Coordinate. We can't accurately find the answer because
Yeah, we don't know if it's.
I didn't tell you what axis it was. Yeah, you're right. Yeah. Okay, so first of all, there's the easy way to do C. And the easy way comes because A, we already did the work up here. And then B, if you understand the concept well, the idea is that this number here that I got from Amia tells us that the particle went 2,580 spaces.
To the right.
Now, if we're thinking of the x-axis, we'll say to the right. Okay. Well, if I started at 10, if I started at 10 and then I moved 2,580 spaces to the right, that's going to put me at 2,590. Now, the more complicated way to do it is, but it's valuable, is to know that your final position is equal to your starting position plus your net change. And this should also be 11, by the way, which is this. Now, S of 11 is 10, and this is 2,580. So when you add them up, you get your final answer. Okay? Now, why do I think this is important? There's a lot of questions where they don't just ask for this answer after you've already done the footwork. A lot of times they just ask for the answer without asking you to find displacement first. So you need to know how to set it up. Another reason why is because sometimes you guys have already seen it in your FRQs where it says write an equation to represent the final position. And that's how you would do it. Okay, so it's good to know how to set that up. Yeah.
Will it ever be the starting position added to the distance? Or was it always
No, that's the reason why that won't. So Nikolai's question, I had 2 people ask that, so I'll answer it. Nikolai asked, why is it going to be starting position plus displacement and not distance? The answer is because of what? The answer is because of. Thank you guys, I appreciate your sympathy. The answer to that is because of what displacement is versus what distance is. Displacement takes into consideration direction. So like, let's say for instance I start off at 1 and then I told you, now remember the question here is where do we end up at, right? So if I told you I went 5 units to the right and 3 units to the left, where do I end up at?
3.
Let's see if you're right. So 5 units to the right puts me at 6.
Oh, yeah.
And then how far to the left did I say?
3. I was right.
Okay.
Yo.
Now, that's my displacement. My displacement is from here to here. That's 3. That's my displacement. I ended up, oh, is it 2? So my displacement is 2 because I'm 2 spaces away from where I was. Now, the distance is 6 plus 3, which is 9. If you take 1 and you add 9 to it, what does that tell you? Nothing meaningful. So that's why you won't ever really add your distance to the original coordinate, because coordinates are about direction, aren't they? Positive 1 is to the right, negative 1 is to the left, and so is displacement. Displacement is positive and negative, but distance is its own thing. It's an absolute value. It's separate. You can't. It's not really going to communicate with the other number well for anything meaningful. All right. So there's that. How are we doing on time? Okay. That's where I wanted to stop today, so we're good. So we will continue tomorrow. Yes, you do. Your homework, guys, is a